Welcome to our YouTube channel. So today we'll be talking about a special ship type. It's called a car carrier. Car carrier or PCC, PCTC, which means pure car carrier PCC or pure car and truck carrier PCTC. All these car carriers falling under a common ship category called RoRos. RoRo means roll on and roll off. So roll on means you are rolling something and bringing that cargo on board the ship. Rolling off again, rolling something and bringing the cargo out of the ship. What are you rolling? You will be rolling the wheels of the cargo or wheels of the equipment which the cargo is kept. In other words, it will be motor vehicles, and you can even bring something on a forklift, on a trailer, tow something. So all whatever going to be rolled or something on wheels will be falling under this roll on roll off category, and they'll be loaded on board a car ship or a vehicle carrier. If you've not seen a car carrier, you can think of a multi-story car park having so many levels, so many floors, and so many cars can be parked. You've seen in many shopping malls, hospitals, hotels. Just like that, you'll have a lot of cars parked inside a ship in so many levels. And in the ship, we don't call levels, we call decks. Car carriers carry on board a wide range of cargoes, varying from cars, trucks, buses, machineries, farm equipments, industrial vehicles, road construction equipment. So when I say equipment, it could be anything, a vehicle or something, a machinery which is kept on wheels or taken in by a forklift. Also trains, helicopters, boats, yachts, so many things, even aircraft parts can be carried in a car carrier if they can be kept on a trailer or if they can be brought on wheels. Today our focus is to discuss one special area, one special aspect of the car carriers, that is the hazards on board or hazards present in a car carrier. When you consider hazards can be of two types, which means design related and operational related. When I say design related, that means design of a car carrier, it carries some inherent hazards. When we want to discuss design related hazards on a car carrier, we need to consider the IMO classification of ships. So IMO classifies two classes, that is class A and class B. Class A represents ships with less sea openings and stringent subdivision rules. Therefore, these ships are better protected from sea. These ships are very common and they are the ships with continuous hull protecting from the sea. And also they have adequate number of transverse subdivisions, transverse bulkheads to control flooding. When we consider the class B ships, ships with higher freeboards and less stringent subdivision rules. So the car carriers, they fall under class B rule. However, the huge tall hull which you see on a car carrier is not actually its freeboard. Freeboard is at a lower level. The freeboard of a car carrier is measured to its ramp level. That is the freeboard deck of a car carrier. So if you see where the ramp is located on a car carrier, you can roughly make out where its freeboard deck. Certain car carriers have ramps located even below the so-called freeboard deck, mostly in the midship section, mostly located one deck below the so-called freeboard deck. So let's see some design hazards that are common to car carriers. These ships are not protected by a continuous hull due to the openings on hull made for rampways at various locations. The hull of these ships are not continuous, and these rampways or the openings are protected by ramp doors, or we simply call them ramp. These ships have a high chance of water ingress due to the low freeboard. Although they fall under high freeboard category, they have a less freeboard when compared to other ships of same length or the size. And on top of that, these ships will have less draft with when compared with similar ship size or the length of another type. These ships have comparatively less draft. Due to this less draft, these ships are highly unstable in water. Due to the large tall hull with a little draft, car carriers are often referred as balloons on water, as they are highly susceptible to wind and water actions. Also, these ships have low metacentric heights that we call low GM ships. If a ship is having a low GM, it means the ship is having less or reduced stability criteria. So even without hull damage or watertight integrity compromise, car carriers are always at risk of reduced stability. These ships have very less number of transverse subdivisions, which means transverse bulkheads, transverse subdivisions, which subsequently provide very good damage stability. Car carriers, on the other hand, inherit a big compromise in damage stability criteria. So car carriers have minimum transverse bulkheads compared with another ship of the same length of a different type. Because other ships will have so many number of cargo holds, and each cargo hold will have a separating bulkhead, transverse major bulkhead. But in car carrier it is not there. Even with cargo tanks, you have so many subdivisional bulkheads. So with compared with other ships which have number of cargo holds or cargo tanks, the car carriers don't have that many subdivisions and that many transverse supports or bulkheads. They are prone for progressive flooding because the less number of compartments means the flooding can be very high. Even with the very few watertight transverse separations that are available on a car carrier, those subdivisions are not extended to the very top or to the entire height of the visible hull. They are extended only up to the so-called freeboard deck or the ramp deck. This could allow progressive flooding in case of a hull damage or hull failure, causing heavy listing or even capsizing due to the watertight integrity compromise. Bulkheads, which are extending up to, we said they extend only up to the freeboard deck and not even to the entire hull of height of the ship. But even that, they are not continuous. So these bulkheads, which is the very few bulkheads which are present on a car carrier, have openings in them as well. And they are not small openings, they are huge, big openings to let the vehicles pass through. So they have watertight bulkhead doors fitted on them to open and close during cargo operation. Watertight integrity can be easily compromised in the event of any of the doors malfunction or lose its watertight integrity or sealing capacity. Car carriers lack longitudinal subdivision. They don't have longitudinal subdivisions between the ship sides. That means inside the car carrier there is nothing between the ship sides, any bulkhead, any separation longitudinal. So no longitudinal bulkhead or separation. So ship side to ship side it is open, and this will allow free surface. So any flooding will have any flooding can be a progressive flooding, and it will have massive free surface effect. Free surface effect has no control in case of flooding. When compared with two possible events between a single compartment damage to a car carrier and a multiple compartment damage to any other vessel. Now a car carrier has a single compartment damage and any other ship has multiple compartment damage. Still, progressive flooding and free surface effect on a car carrier would be much higher due to its design. There was an event where in somewhere early 2000, probably 2001 or 2, a vessel called Tricolor, a car carrier. In the North Sea, it had a collision with another vessel, a different cargo vessel, and that ship, Tricolor, had a hull rupture. And it took very little time for the car carrier to capsize and submerge. When the master went to the bridge wing and ship started listing, when just after the collision, the master could not come back to the bridge. It was so fast, the listing was so quick, and ship capsized. Height of the lifeboats, life raft and embarkation ladders could also pose a higher safety concern due to the time consumed when launching. Certain design hazards, as we discussed earlier, also contribute to operational hazards. Since the hull is not continuous, the watertight integrity of the ship can be easily compromised in case of a contact damage. If the ship goes and hits somewhere, and if it hits one of these ramps, of course the ramp will not seal properly. That area gets damaged and ship will lose its watertight integrity. Residual stability of a car carrier can easily be compromised due to its low freeboard in the event of leaky ramp door during heavy weather conditions. In many car carrier designs, there are ramps in the midship section with rampways located below the freeboard deck. And any of these ramps starts leaking in heavy weather, the residual stability will be lost very quickly. So the ramp doors have locks, cleats, just to keep them in place once they are closed, and to keep that tightly closed. Suppose the locks malfunction, they start opening. Locks don't keep the ramp tightly closed, and the ramp losing its sealing capability. So the rubber packing, whatever around that rampway, there will be a huge big rubber packing. So if that loses its sealing capability, can be disastrous and would immediately make the vessel unseaworthy. If the ramp is not locking, ramp is not closing properly, you are not going to be seaworthy. Accidental opening or collapse of the ramp doors due to lock failures, structural failures, or weather-induced reasons, and also human error are quite possible. So due to the weather, due to misoperations of the ramp when handling, and age-related factors, structural failures, maintenance issues can easily make these ramp doors or this water tightness at the ramp doors very troublesome. If any vehicle, any machinery, any forklift, any big vehicle, anything goes and hits the rampways, which is close to the ship side, or the internal ramps, which is inside the ship, some internal ramps, and all those watertight bulkhead doors. Any of those components, they get damaged during the cargo work, will easily make the ship unseaworthy. Until such damage condition is rectified again, the ship will remain unseaworthy. So people on board car carrier have to be very careful when during cargo operations not to have any damages occurring to these components, and they should be watching these areas. These vessels are very sensitive to heeling moments. Early actions to avoid collision, early alteration of courses, careful and controlled course alteration or turning of the vessel according to the speed and stability condition at certain stowage conditions is much preferred to avoid excessive heeling. These ships can experience drifting, heeling or rolling even when the other ships of other ship types are steady and stable, when they behave steady on water. Due to the balloon-like qualities contributed by the tall hull and shallow drafts, these vessels are very sensitive to wind and wave actions. Due to their large windage area, car carriers often drag anchor too early. Critical wind velocity is a very important factor to consider when deciding to anchor a car carrier. Therefore, car carriers often opt to stop and drift to avoid remaining at anchor. Wind action similarly affects a car carrier during drifting as well. Drifting rate of a car carrier would therefore be much greater when compared with another vessel. The car carriers, they try and avoid anchoring because when the wind picks up, before any other ship drag anchor, the car carriers will start dragging anchor due to the large windage area. So the large windage area will cause the wind action to cause the car carrier to drag the anchor too early. And to avoid this, the car carriers mostly they opt to stay adrift. And then drifting is also a concern for the car carriers when compared with other ships, because wind action will also affect during drifting. So compared to any other vessel's drift rate, car carriers will have a bigger drift rate. So due to this reason, the car carriers, even when they opt to drift, sometimes if the wind is strong or if they are not able to stay in a small area drifting, they opt to move slowly using engines. So they start their engines and keep moving slowly because they may not be able to stay at one place when the wind is getting little strong. So not only at the anchorage, not only when drifting, but even at berth when they are tied up alongside with ropes, all the ropes or maybe with additional ropes. If the wind picks up to become a little strong, car carriers are known to part their ropes and move out of the berth. And even sometimes during the cargo works, if it happens suddenly, they are not even having times to secure their ramps, and their ramp structures, the cargo can get damaged. And then if this moving out of the berth is not controlled immediately, if they don't receive assistance like tugs, the car carrier can move away from the berth and even damage some other vessel or another structure. So it's quite possible for car carrier. It has happened quite often that during strong winds they even part their ropes and move out of the berth. So it's not seldom that car carrier masters, they call for tugs and keep the tugs standby when the wind's blowing. It is a real test of the master's skill and confidence when handling a car carrier in relatively strong weather and of course in heavy weather. Approaches to a port, waiting for pilot, picking up pilot, entering, leaving locks will be a big challenge for any car carrier master. Due to this easy listing or heeling, due to the wind action, since they are very tall ships and they can very easily list, very easily heel with the wind, or even cause alteration, small tank level change. The ships, they try to keep their GM little more, and this will result in in making the ship stiff. When you increase your GM, lowering your metacentric height, the ship becomes very stiff, so relatively stiff, and it will reduce the rolling period. Quick and violent rolling will have massive stress on ship side structures, and these ships, as you know, don't have supporting transverse bulkheads as well. So this kind of violent rolling will have very adverse effects on the ship structures. And also whatever the cargo lashed on board, the cargo lashing material will have also enough stress. They can even fail and break off the lashings. The cargo can move. This rolling will increase the chances of motion sickness of the crew. Car carriers don't very often do taking the ballast in from outside or pumping out the ballast from the tanks. They just try to maintain their ballast, the standard amount, and just do the transfers internally between tanks to adjust the list and the trim. If that ballast is giving you adequate sufficient GM when the ship is fully loaded, but the same ballast, if ship is empty or not having so much of cargo, then relatively high GM will be there, and that will make the ship relatively stiff. This can again cause violent heeling or less rolling period. So when the car carrier is very sensitive to wind and water movements, quick rolling, heeling, the cargo on board can easily shift. The lashing fails and the cargo can shift. So the lashings get loosened, the cargo may shift. So what happens initially is the lashing can get slowly loosened up, and then there is a small moving movement, and this movement will loosen the cargo lashing further, and then the lashing can get more loose and the cargo is free to move and the lashing can come off. There had been an incident where a heavy vehicle has got its lashings loose. Ultimately, the lashings had failed. The vehicle had become free to move. The ship had almost been with very little cargo. There hadn't been much cargo on board. So this heavy vehicle had gone and hit ship structure like a pillar, and with couple of hits it had got its hydraulic tank damaged, and hydraulic oil had spilled, making this the surface, the deck area, very slippery, and has caused the truck, that heavy vehicle, to move more freely, and it had moved so freely between the ship side and hit the ship side few times, ultimately damaging and rupturing one of the ship sides. So it is very much possible for this kind of incidents to happen again and again if the lashings get loosened up, if the lashings are not checked, and if the rolling or the heeling is not controlled. So when the lashings fail, it is very much possible for not one cargo unit but for many cargo units to move. And with the rolls, if the cargo gets collected onto one side, and that listing can never be corrected, the ship will ultimately be listed heavily to that side. And if it is during a very bad weather condition, it will be not a very good thing. Height location of the lifeboats, life rafts, embarkation ladders is a big concern. These ships, if they are susceptible for progressive flooding, if they can capsize very quickly and go underwater very quickly, and there won't be much time enough, because those survival crafts are located at a much higher level. Embarkation ladders could be very long, so launching these survival craft and boarding them would of course take time. So it is a big question whether the crew would have sufficient time to launch and board the survival crafts. It is very much important to monitor all the stages of cargo operations, confirm and reconfirm the loading or discharging sequences, and always keep an eye on the stability of the ship. If they don't follow proper loading sequence in relation to the stability of the ship, if they load so much on top and the top gets heavy and the ship loses its GM, the ship can capsize even during the cargo due to reduced or negative stability. Because it's very easy for a car carrier to have a violent excessive heel in port or during navigation. The decks inside the car carrier, car decks, certain decks can be height adjusted. So if you are loading fairly high cargo on a deck, just to make room for that cargo, you can lift the deck above. The liftable decks of the car carrier are not continuous. These decks broken down into so many deck panels, so they can be separately lifted to adjust the height. So you can adjust that height in order to load both the decks or completely lift and have the top deck unusable and all the room for the deck below. Those deck panels, when they are lifted, they need to be secured properly. They have locks. So if they are not locked properly, secured properly, they can fall. There had been an incident in a ship where the height adjusted deck panel was already having cargo loaded on top of that, on that deck, and while the cargo work was ongoing, that panel with the cargo and the people had fallen down to the deck below. Because it was not locked or secured properly. One end, one of the four corners of that deck panel was not secured properly. It is very important to make sure all the deck panels, once they are height adjusted, to reconfirm that the locks are secured properly. The kind of cargo loaded in the car carrier poses a big risk. Mostly motor vehicles. You have hydrogen fuel cell vehicles, you have lithium ion vehicles, you have ordinary internal combustion vehicles. So everything can catch fire. Danger of fire is on the increase in car carriers. Danger of fire due to cargo is on the increase. They have fuel inside them, their battery is connected, and the new danger is those hybrid or EV, electrical vehicle with lithium ion batteries. Because these lithium ion batteries, fire breakout, they cannot be extinguished. The car carrier can have massive uncontrolled fire and explosions if occurs. There had been instances that cargo, when they loaded, which was lying on wharfs or some waiting areas, snakes gone inside those cargoes, and once they are loaded on board the ship, the snakes come out. Not only snakes, even small animals had been hiding inside these cargoes and packages, and once they are on board the ship, they had come out. So the ship's crew had to face the snakes and those small animals. Car carriers, sometimes they have to carry military cargo, and the cargo, this military cargo, means a lot of firepower. They may have a lot of arms, ammunitions, explosives inside. So that will again pose a bigger fire and explosion danger to the ship. In addition, the ship is marked by the authorities. Sometimes you have declaration issues, and then if you know a ship is carrying so much of weapons and these items, it will also draw attention of other parties who wants to get hold of that. maybe in an easy way, like pirates. So that again another hazard on car carriers when they carry military cargo. Marking the route with cones and cordoning off the openings, setting barriers, all that is very important in the car carrier. And adequate lighting is very important. Signage is very important. So all that is done by the ship staff, so that the drivers, they can just follow those marks and go in and out without going wrong way. And sometimes due to human error by the ship staff or the stevedots, still accidents take place. When the decks are lifted, if they drive the wrong way, and they can fall off from opened end. A ship called Cougar Ace, a car carrier, in 2006. In the Aleutian Islands area, near to Alaska, while carrying out a ballast exchange, lost its stability and listed heavily, almost like capsized, but so much of angle it listed. Ship's crew were evacuated from the ship and rescued by the US Coast Guard. In 2016, a ship called Modern Express, which carried vehicles, machinery and even timber inside the car decks from Africa, during transit of Bay of Biscay, met with heavy weather and the cargo shifted, and the ship listed heavily onto one side and lost all its power and propulsion.
The Modern Express, a 164-meter long roll-on roll-off vessel, was en route to Le Havre in France on the 26th of January 2016 in heavy weather when she lost stability.
Sur de possibles conséquences écologiques.
La cargaison ne présente pas de danger pour l'environnement.
So the ship's crew evacuated the vessel. They were rescued one by one, lifted off the ship by a Coast Guard helicopter.
Coast Guard rescues 22 sailors off the coast of Spain. Spanish Coast Guard responded with helicopter support to lift all 22 sailors to safety.
And later on, the ship was towed to one of the ports in Spain when the weather was fairly bad. Another vessel, which was almost brand new in 2015, named Hogue Osaka, during outbound passage from Southampton, while taking a big turn, listed heavily and almost capsized. When the ship started listing heavily and going to capsize, the pilot decided to beach the vessel, and the ship just heeled over and sailed. That was also again due to the reduced stability. In 2019, a vessel called Golden Ray capsized in Brunswick, USA, due to loss of stability. Recently, a few weeks back, a vessel called Felicity Ace caught fire while transiting the Atlantic from Germany to USA. The fire spread out, the crew were evacuated. And then the fire extinguished. Later on, ship sank. So this is a small discussion on hazards present on car carriers. I hope you gathered something from here, something important for you to carry on, and hope to meet with another video to learn something new. Thank you.